My name is Aguillard, and I'm a member of Group 1, and today I'll be doing a 6-minute thermal talk on the Wankel rotary engine. So, the Wankel rotary engine is a type of internal combustion engine that was invented by a German guy named Felix Wankel in 1929. And it uses the typical 4-stroke Otto cycle that most piston engines use, except instead of using reciprocating pistons, it uses a rotating triangular shaped rotor. So it goes through all the typical cycles, the intake, compression, ignition, and exhaust, except that the way it does it is a little bit different. So here's a couple of animations. So on the left, you've got the typical reciprocating piston engine where the total event happens in 4 strokes. So the first one is on the downstroke, the intake valve opens and pulls in ambient air, and then on the upstroke, the valve closes and compresses all that, and then at the top, the spark plug fires and pushes it back down, which is the power stroke. That's how it creates the power. And then when it goes back up, the exhaust valve opens and it pushes all that out. And in a rotary engine, all of that happens as the rotor is spinning in the same direction the whole time. So on the tips of the rotor, they have these little seals that block off each chamber around the rotor. So there's 3 chambers around it. And so as the seals pass the holes, it opens them up and kind of seals it off after it passes the hole up. So you can see that the animation's a little fast, but as it goes past the intake hole, then it kind of grabs that air and then it seals it up, and then as the rotor goes around it, the area gets smaller and it compresses it, and then it still uses spark plugs to ignite it, and that pushes the rotor around the rest of the way. So there's a few advantages to using an engine like this. It's less complex because there's a lot less moving parts. You don't have valves opening and closing, and you don't have, I guess it's just valves really. You don't have to have camshafts to activate the valves and all that. And it's also smoother running because in a piston engine, the pistons are constantly moving up and down, and that like reciprocating motion causes a lot of vibration in the engine. And but in a rotary engine, the rotor is always spinning the same way, and it spins the same direction as the crankshaft, so it's all pretty balanced, and you don't get as much vibration. And since they're less complex, and since there's less vibration, it allows them to rev out a lot higher. Usually, piston engines can only rev to like 6,000 or 7,000 RPM, but rotary engines can commonly get up to 10,000 plus. And you get a higher specific power output. So for a specific displacement, it's going to make more power per displacement, and they usually have a better power to weight ratio too. But also, like anything, there's disadvantages. And these disadvantages are the reason that rotary engines aren't really used very much anymore, because they have a pretty poor fuel efficiency and emissions. So the main problem with this design is the shape of the combustion chamber. It means that a lot of the fuel doesn't get burned properly, and you end up with a lot of unburned fuel in the exhaust. And then with the design of the seals on the edge of the rotors, as they sweep past the spark plug holes, some of the fuel and air, since it's pressurized, it leaks past the sealed air, and then so you just get plain unburned fuel in the exhaust. And so that means the fuel efficiency and emissions are pretty bad on these. And so Mazda is pretty much the only automaker that used rotary engines in their production cars, and they stopped recently because they couldn't get them to meet the more stringent fuel efficiency and emissions requirements. So you don't really see these much anymore, but it's still a cool design, and I think that with like, more research and development, you could make it a little bit better. And these are my references. Any questions?